Okay, here we are on trigonometric functions, page 1. Periodic behavior. Give an example of periodic behavior that you see in the environment. You could say a lot of different things here. You could say like the tides, or you could say the moon, position of the moon. You could say the time of day, the sun rises. Okay? All right. This repetition may be called periodic, or I think the book uses words like cyclic or oscillatory. Okay. A periodic function repeats in a horizontal direction. In intervals of the same length. The length of one repetition or cycle is called a period. F of x is a periodic function with period p, where f of x plus p equals f of x for all x, and p is the smallest possible value. Okay, smallest possible positive value, something like that. Okay, so does that make sense? Basically, f of x plus p equals f of x says, hey, if I have a repeating pattern like this, then p is if I take this whole thing and I shift it back that much, then I'm going to get the exact same thing. See, like I shift it back that much, and hey, look, it's exactly the same. Do you get it? So p would be the amount you have to shift it back, the smallest amount p that you shift it back before it starts repeating, okay, which is called the period. Basically, that's one full cycle of the repeating function. In a wave function, what is the equation to find the principal axis or mean line? So in a wave function, or something like this, the mean line is the line that goes right through the middle. Okay, and the way you find it is you can take the average of these two levels here, the top level and the bottom level. So you could say the y equals the min plus the max divided by 2, which is the equation to find the mean, or the average. What is the equation to find the amplitude? The amplitude is like the distance between the orange line in the middle and the blue line at the top. Or it could be between the orange line in the middle and the minimum value at the bottom. The easiest mathematical way to find it would be to take the maximum minus the minimum, and then to divide that difference by 2. That would give you that distance from the orange line to the top or the bottom. Okay, label the maximum point, minimum point, and the principal axis, mean line, blah, blah, blah. So the maximum point I'll make blue here. The minimum point I will make red. Okay, and the principal axis line I'll make orange. Okay. And the amplitude of the diagram would be, I'll make purple. It's just like this distance, or this distance, or this distance. They're all the same. Okay? All right. Moving down. Which of these diagrams show periodic behavior? Well, remember, as long as the pattern repeats over and over again in the horizontal direction, then that's periodic. So we can see that it's repeating. So yes. And this too, right? It's like this cycle here is repeated, right? Over and over again. So yes. This one too, yes. It's just a sine wave. What about this one? Well, this one kind of looks like it's repeating, but it's not repeating in the horizontal direction, right? It's repeating like in the diagonal direction. So no, this is not periodic. Number 3, draw a scatter diagram for each set of data below. Is there any evidence to suggest that the data is periodic? Okay. Well, when I look at this one here, I see kind of a pattern repeating, right? Do you see like now it's repeating again, 0, 1, 14, or 0, 1, 1.4, okay? So this does have some evidence. The one down here, I can't really see any obvious repeating pattern, but luckily we can use the GDC to graph these points, and if we do that, then it becomes very easy to see if it's a repeating pattern or not, even if you, like in B, it's not obvious, right? So we're going to do stat, edit, and then we're going to put the x coordinates and the y coordinates of these points into stat edit, and then we can graph them. Okay, so at first I'm clearing out these here, but so let's do it for B here, because this one is not obviously repeating. So I'm going to put 0, and I'm going to put 2, and I'm going to put 3, and 4, 5. You have to be kind of careful because some of these are getting skipped, but I'm not going to make you watch me put. So I just typed all these numbers in. You can see they skipped 11, so I'm not going to put 11. Then I'm going to go to the right, and then I'm going to put in the y values in the L2 column. So first one is 0, second one is 4.7. Okay, and then I'm just going to continue here, and I'm not going to make you watch me type all these in. So I've completed both columns of data for B, and then I'm going to go, oh, and I have instructions here on how to do this right here at the top, right? And so to actually, to make it print, we're going to go to second y equals, which is stat plot. And then we're going to say, hey, I'm going to print L1 and L2 with a scatter plot. So it would be like this one here. And so I'm just going to say that, hey, I want a scatter plot, which is that one. I'm going to turn it on, and X list is L1 and Y list is L2. Okay? And that's it, I think. Okay? And then I'm going to graph. And then I need to zoom in a little bit because you can't really see it, so I'm going to do zoom and zoom stat, which is option 9. Enter. Oh, and there we go. Okay. Now, let's see. Does that look periodic? It looks kind of okay up to here, but then this doesn't. So no, that doesn't look periodic to me. Okay. All right. Recall from the investigation the effect of changing the variables a, b, c, d. Okay, so from the investigation, we use sliders to change each of these variables, and so we kind of know what each one does. A makes the amplitude bigger. Okay. B makes the the period smaller. If you make B bigger, the period gets smaller. C shifts to the right if you make C bigger. And D makes shift up. Okay? All right. Now, without using technology, sketch the graphs of the following but for x between 0 and 2 pi. So remember, I'm just going to do sine x first. Okay, sine x ranges between 1 and -1. starts out at 0, okay, and then so it ranges between 1 and -1 like that. Now if you want to remember what sine starts at, just remember that the sine of 0 is 0, so it starts out at 0. And then the sine of 90 degrees, or pi over 2, is 1, so then you know that's 1. And after that, you can just draw the rest of it, right? Pretty easy. Okay, now, what if instead of sine x, it's 3 sine x? Then what do you do? So then you have, go through 3, and you go through -3, right? Because instead of sine x being ranging from -1 to 1, it's going to range between -3 and 3, so everything's just going to get taller, okay? Now let's look at this one. Y equals 3 halves sine x. So for this one, instead of becoming taller 3 times taller, now it's going to become 1.5 times taller. So instead of ranging between 1 and -1, it's going to range between 1.5 and -1/2. So it's going to look kind of like that. All right. Number 2, without using technology, sketch the graphs of the following for x between 0 and 3 pi. So let's see. Let's say that this is 0, and this is, this is pi, or 2 pi, and this is pi, and this is 3 pi. Okay. We're going to take y equals sine of 3x, and we're going to graph it. Okay? And remember, this is the b slider. So when the b slider gets bigger, the period actually becomes smaller. Okay? So, like, when would the cycle, when would a 1 period or cycle end for sine? Sine of 2 pi is when it becomes 0 at the end, like that, right? But if you have sine of 3, you actually don't need 2 pi to get to the end of the cycle. If you put 2/3 pi in there, then you're already going to be at the end of the sine wave. Okay? So instead of repeating the sine wave every 2 pi, you're going to repeat the sine wave every 2/3 pi. So like that would be about there, and the next one would be 2/3 plus 2/3, which would be 3/2 pi, which would be right there, and then another 2/3 would be here, and then here. So the sine wave would repeat itself three times every 2 pi. So like for example, here you'd see one, and here you'd see another one, and then here you'd see another one, and here you'd see another one. So you would actually see 1, 2, 3, 4 repetitions between 0 and 3 pi. Okay, and you would see a little bit more than 2 repetitions between 0 and 2 pi. Okay, what about this one here? Sine, and let me say, okay, we did this one in orange. We'll do this one in pink, okay? So sine of x over 3. So this is kind of going in the opposite direction. Instead of, now to get 2 pi out, we're going to have to put a really big number in for x, like 6 pi. If we put 6 pi in for x, then we're going to get 2 pi out. So the sine cycle is going to occupy 0 to 6 pi instead of from 0 to 2 pi. And so we can see that here the sine wave would be like very wide. Okay, so instead of, it would actually take 6 pi to finish the sine wave, but half the sine wave would finish at 3 pi. Okay, so that's sine of x divided by 3. Now it says, state the period of y equals sine of 4x and sine of x over 3. The way you figure this out is, you know that 4x is equal to, if you set 4x equal to 2 pi, basically that's saying is, what is the full cycle of the sine wave? And you can see that it's going to be 2 pi divided by 4, which is pi over 2. So it's going to be 4 times smaller than a regular sine wave. So it's actually like it goes up and down much faster. Okay, so it's pi over 2. And then what about for this one? You're going to set x over 3 equal to 2 pi, and then you're going to find out that x equals 6 pi. So in this case, it is much wider, right? The period is going to be 6 pi. And actually, that's the same as this one, right? This is the same problem as this. Okay, so we've just discovered by setting x over 3 equal to 2 pi that the full sine cycle takes 6 pi to finish. Okay, and one sine cycle looks like that, right? It goes up, goes down, it goes back up again. All right. Number 4, find b given that the function y equals sine bx, b of greater than 0, has period 5 pi, 12 pi, or 100. Okay, so let's say, okay, we're going to set sine bx, we're going to set bx equal to 2 pi because that's one full period. But what if, let's see, what if the period is, let's see, what if the period is 5 pi? So what they're saying is you put in x of 5 pi and then you multiply times b and you get 2 pi out. So what's b? So b is equal to 2 pi divided by 5 pi, which is 2/5, right? So that's first b. What about if the period is 12 pi? So then we have bx equals 2 pi again, and the x here is 12 pi. So b times 12 pi equals 2 pi. b equals 1 over 6. Okay? And then finally we have bx equals 2 pi, and then the b is multiplied times 100, and that's equal to 2 pi. So that would be b equals pi over 50. Okay? So those are the 3 periods of the sine waves here.